Hey everybody. So we're learning about why we have seasons now. So of course we know all the seasons. We've got summer, autumn, winter and spring. But the reason we have seasons is actually due to a few different factors to do with the earth and the sun. And we're actually going to start by looking at a misconception again. This is something people always get wrong, even adults who don't understand how the seasons work. So a lot of people think that we've got the sun in the middle of our solar system, which is true. Then we've got the Earth. But a lot of people think that the Earth's orbit is really oval shaped, like this, so that when the Earth is far away from the sun, like here, then we're in winter. But when the Earth is closer to the sun, on this part of the orbit, then that's going to be summer, because it's hotter. But that's not correct at all. The Earth's orbit is, yes, it's a little bit oval shaped, but not enough to make that much of a difference. And actually the Earth's orbit's closer to being a circle than anything else. So forget about that. We're going to focus on the 3 reasons why we have the seasons. Okay. So the first reason is that because the Earth is a sphere and is spherical, then different parts of the Earth get different amounts of sunlight. Because Earth is spherical, different regions, they receive different amounts of sun. And sunlight is what causes the seasons, because if you have more sunlight hitting you through the day, then that warms up everything, and that's what people have in summer. So if we have the sun here, much closer than it really is, and if we have a look at the sun's rays, and if we imagine them as tiny little lines, which they basically are, well, we can see that the part of the Earth that's closest to the sun here, and these are called the tropical regions, or the tropics, they're receiving a whole lot more of the sun's rays because the sun is directly over their heads. So most sunlight hits in the tropics. Which is the closest point to the sun. Okay, and then if we look further down, like we're down here in Melbourne, well, this southern area here, it's receiving a whole lot less light because the sunlight's on an angle, and so it spreads out more. So the regions further north and further south, they're getting a whole lot less light than the tropics are. So these regions receive less because the light is spread out more. So that's the first thing we need to remember. But the next thing is that everything we've learnt about the Earth's rotation so far is actually not quite right. So we've imagined that the Earth has its axis of rotation going perfectly straight, perfectly vertical. But actually, scientists figured out that the Earth's axis of rotation is actually tilted. And that's the second important point. It's tilted, and generally it's about 23.5 degrees tilted, which you can see here. So we looked at our spinning top earlier on, and if we're imagining Earth as a spinning top that's rotating, it's actually facing sideways as it rotates around. It still has an axis of rotation, but that axis is on an angle. So here's the true picture of what Earth looks like as it's rotating. And that's why, if you've ever seen one of these globes, that's why the Earth's on an angle. Because the people that make globes have decided to make it as accurate as they can to show that tilt. So if we put those things together, that means that at different times of the year, different regions of Earth are going to change how much sunlight they get. And that's the third point. And particularly, the northern hemisphere and the southern hemisphere, they're going to alternate how much sun they get. So the northern hemisphere up at the top, where America and Asia, most of Asia and Europe is, and the southern hemisphere where we are, they're going to get different amounts of sunlight at different times of the year. Of the year. And that's the most important point. So let's have a look at this example here. Obviously, this is not to scale, but the tilt of the Earth is to scale. So in the first situation, because the Earth is tilted at this point, then these regions in the northern hemisphere, they're getting a lot more sunlight because it's closer to being to hitting the Earth head on. So at this time of year, the northern hemisphere is in summer. And if we look at us down in Australia here, because the Earth's tilted, we're facing on quite an angle away from the sun. So we're only getting a few rays of sunlight, and they're on an angle as well. So we're in winter. Southern hemisphere, winter. But as the Earth orbits around the sun, so in our winter that's about June, July, well, 6 months later, in December and January, the Earth has orbited over to this side. And now you can see Australia is almost facing head on to the sun. So we're getting all those rays of sun much more directly, so we're getting a lot more energy. So obviously that means at this time of year, the southern hemisphere is in summer. And then if we look up at the northern hemisphere, all those countries are getting sunlight on an angle, so they're not getting as much energy, so they're going to have winter at this time of year. We haven't talked about it, but that means that at this point in the orbit, and then at this point in the orbit, well, all the regions are going to have a similar amount of sunlight. So that's why we have autumn and spring, because they're halfway between. And so that means the northern hemisphere and the southern hemisphere are getting a similar amount of energy. So they have similar temperatures to each other in autumn and spring. Okay, so those are the 3 important points about why we have seasons.